Hello, bright minds. Quick question. Have you ever looked into a shiny spoon and noticed your face doing funny things? Sometimes you look like a giant balloon, and sometimes like a squashed potato. That, my friends, is the magic of spherical mirrors. A spherical mirror is nothing but a piece of a hollow glass sphere that's been silvered to make it reflective. So, unlike a flat mirror, here the reflecting surface is curved. Depending on which side is silvered, we get two types, concave and convex mirrors. So yes, next time you see your weird face in a spoon, remember, that's not a cooking accident, that's physics in your kitchen. Let's classify them clearly. If the outer surface of the sphere is silvered, the inner hollow part reflects light, that's called a concave mirror. But if the inner surface is silvered, the bulging outer surface reflects light, and that's called a convex mirror. Both are curved, but their behavior is opposite. Concave focuses light, convex scatters it. That's why one is used in telescopes and shaving mirrors, while the other keeps an eye on you in shop security mirrors. So, think of concave as the mirror that zooms in on you, and convex as the one that's trying to catch everyone in the frame. Now let's zoom into the concave mirror. Imagine silvering the bulging outer surface of a glass sphere. The inner hollow part becomes reflective. Light rays striking this surface reflect inwards, converging at a point called the focus. That's why concave mirrors are also called converging mirrors. This property makes them useful where we want concentration of light, like in torches, headlights, solar cookers, and even shaving mirrors to see a magnified image. As you can see in the diagram, parallel rays come in and meet at one sharp focus point. It's like a mirror saying, "Everybody come here, let's meet at the focus." Now let's flip things around. A convex mirror is made by silvering the inner side of a sphere so that the outer bulging part reflects. Here, rays of light don't come together, instead, they spread out after reflection. So convex mirrors are called diverging mirrors. They always form virtual, upright, and diminished images. That's why they're perfect for car rear view mirrors. They show a wider field of view. Even though objects look smaller, you see more traffic around you. So, the convex mirror is like that friend who always tells you, don't just look at yourself, look at the bigger picture. Let's put them side by side. Concave mirrors, reflecting surface is inside. They converge parallel rays, can form real or virtual images, and magnify or diminish depending on distance. Convex mirrors, reflecting surface is outside. They diverge rays, always give virtual and diminished images, but show a much wider area. So, concave is like a zoom lens, while convex is like a wide-angle camera. Both are useful, but in very different ways. Pick the wrong one, and imagine a driver trying to shave with a car mirror, dangerous and funny at the same time. Alright, let's crack a simple example to test your logic. Suppose we have a mirror made by silvering the outer surface of a hollow glass sphere. Question: which type of mirror is this? Step 1. Outer surface is silvered. Step 2. That means reflection will happen from the inner hollow side. Step 3. If reflection occurs from the inside, it's a concave mirror. Step 4. Concave mirrors converge rays and can form both real and virtual images. Final answer: it's a concave mirror. See, the secret always lies in asking which side is silvered. So, let's sum it up beautifully. A spherical mirror is simply a section of a hollow sphere with one side silvered. Concave mirrors are converging, used for focus and magnification. Convex mirrors are diverging, used for wide views and safety. Your bathroom shaving mirror, your car rear view mirror, and even the giant telescope at an observatory All of them are just clever uses of these two cousins, concave and convex. So, the next time you peek into a spoon or drive past a convex traffic mirror, smile and say, "Ah, that's spherical mirrors reflecting physics back at me." And with that, class, I'll see you in the next lesson. Until then, keep reflecting and keep questioning.